Okay, so I essentially am going to step through the lecture notes, which is, I mean, these are lecture notes I wrote, and it's sort of how I think about the sort of the most straightforward way to learn MATLAB. There are a lot of MATLAB tutorials that you can find online, and it goes to more or less detail on any particular topic, and some of it may not be relevant if your goal is to use MATLAB to analyze data. I mean, there's sort of engineers worry about other aspects of MATLAB and use MATLAB to program experiments. You might worry about other things, so I've sort of focused what I think is most important in the lecture notes that you see in front of you. And I think the way I'm going to handle this is I'm sort of going to talk about the concepts that I'm put in the lecture notes and sort of demonstrate that on the fly in my little MATLAB terminal. And I guess one thing about MATLAB is you won't really learn it until you do it yourself, but it's kind of hard to do it yourself if you don't know what to do. So the first introduction here is I'm going to do it. And it will really benefit you if you really pay attention and follow along and see what happens on the screen and sort of pay attention to, you know, if there's an error message, I'm going to tell you why the error message occurred and sort of, you know, so this is sort of a dynamic or interactive kind of learning, and it will require you to pay attention to what is in the command window. So fundamentally, I started off with the MATLAB environment, and this is sort of how you interact with MATLAB, and it may be different if you're familiar to other programming languages. Like in C, you have to write a file and compile it and all that, but in MATLAB, there's a way of a workflow that's sort of unique, although, you know, Python and other languages sort of share flavor. So in MATLAB, I guess the first concept is a variable. So a variable is going to hold data, can hold strings, can hold whatever you put in it, and I'm going to, in this case, start with a simple variable called a. So in this statement, I've just defined the variable a, which is just a string, and I say that a contains a value, in this case a number. A is 1, so I set a to 1. And once I do that, MATLAB echoes that back out to me, and it says, okay, a is 1, fine. So we can name variables whatever we like. So we can say value or interesting, I mean, basically any string. So interesting value, let's call that a variable and give that a big number, make that whatever number we want. We can use numbers. There's also, let's try to follow along. Here I do mention, let's do a brief introduction to a matrix. So a matrix, we're going to go over that, is sort of fundamental to MATLAB. That's where it gets its name. And you represent a matrix with little brackets. So here I'll just make a simple matrix of 3 numbers. Done. So I've just set this variable to contain this matrix, and MATLAB echoes it back out to the screen just so we know what's happening. Okay, we'll go much more into what matrices are, you know, later on, but I'm just introducing the concept of variable. So we know how to define variables. Okay, so far we've defined a couple of variables. We define a and also this interesting value variable. And they're all defined, and they must exist somewhere. They exist in memory. And to figure out what is in memory currently, we can type this simple command called whos, W-H-O-S. And that reports on the status of the workspace. The workspace is just a collection of things in memory. And it's telling me that we actually have 3 variables. One is called a, one's called ants, and another one's called interesting value. And it also tells us some other information like the size. So this gets more into the innards of like what are matrices. Well, a single number, a scalar, is a 1-by-1 matrix. There's 1 row, there's 1 column. And then this simple vector we defined just a second ago, interesting value, is 1-by-3. 1 row, 3 columns. So it tells us some information about the size of our variables and then some other stuff which I won't worry about yet. Okay, so in MATLAB, the workspace is sort of fundamental. The workspace is the variables that we've defined or loaded in. Unfortunately, you have to keep track of your workspace. If I were to quit MATLAB right now, the memory would be released. You would lose all your variables, and you lost all your work. So in MATLAB, once you've loaded in your data, analyzed your data, and got some interesting results, you got to save your results out. And we will go through that in a second. We already talked about the command window. It's this window that I'm typing in. The GUI we briefly looked at. We could, if you want to know more about the GUI, just sort of offline, you can show me what you want to know about, and I can probably figure it out. Okay, other basics, functions and scripts. So in MATLAB, I mean, so far we've just done simple variable assignment, but there are a lot of built-in useful things we can do. For example, the mean. You want to compute the mean of some numbers. Suppose you have 10 numbers and you want to compute the mean. In theory, we could sort of do that manually. So as you might expect, there are sort of built-in operations like plus. I can say 1 plus 2 plus 3 plus 4, and then using very standard mathematical notation, I can compute the mean just like that. Add the numbers, divide by the number there are, and that's one way to compute the mean. Fine. So in this case, and I've sort of skipped one detail that I guess I haven't mentioned in lecture notes, but here I issued a statement without assigning it to a variable, and that's fine if you want to do some quick sort of calculator. I'm going to add 1 plus 1. I don't want to assign it to a variable, so you can just type it, and that's fine. But implicitly, MATLAB is going to assign that value to a variable called ans, standing for answer. So that there's a sort of slight oddity there, but it's pretty straightforward, and it tells us the answer already, 2.5. So the mean of 1, 2, and 3, and 4 is 2.5. Fine. However, maybe we're lazy and we don't want to actually type all those pluses and divide. Well, there's a built-in function called the mean, and here I'm just going to demonstrate the function, but I'll tell you a little bit more about the syntax in 1 second. So here I'm going to compute the mean of that argument. That argument's a vector, right, using these brackets, and it also tells me the mean is 2.5. So that's good. The function mean did the right thing since I computed it directly. And so the syntax here is, I mean, a function is going to be denoted by a string, a word, in this case mean, and you're going to give it a parentheses to indicate what are the arguments. You're going to give a function stuff, and it's going to spit out an answer. So we gave it one argument, that's just a vector, and it spat out a value, and the value MATLAB is telling us is 2.5. So the very basic syntax here, you use sort of smooth parentheses to indicate sort of our argument list in this case, and then we're going to use these square brackets to indicate that it's a vector or a matrix. So the difference between a vector and a matrix is a vector is just a one-dimensional matrix that just is big along one dimension, whereas you can have a two-dimensional matrix that's big along 2 dimensions, or 3 dimensions, 4 dimensions. Okay, so mean is just a function, and it turns out that, great. So I just did a command called type, which I think, oh yeah, I will cover that later. But for now, all that's happened is I asked MATLAB, what is mean? Mean's a function. Well, a function is computer code. Show me the computer code that underlies this function, and it spits out, oh, this is actually what MATLAB ran when I typed in mean. And you could read through this, and we'll go over the syntax of functions in a little bit, but basically, these are all comments, so this is just text that you can read. MATLAB ignores it. It doesn't actually use it, but it actually executed and ran these commands when I typed in mean. And this is pretty boring, but let's just focus on one line here. So essentially this line, and you don't have to worry too much about the details, but essentially did what I did manually. So it summed the stuff that I passed it and divided by how many elements there are. So I mean, I haven't explained what size is. Size is also a function. We'll get to that. But just intuitively, we can see the innards of what MATLAB is doing. And that applies for whatever MATLAB code you might get from someone. Like, you can look in SPM and sort of look at all of its source code and look through exactly what they're doing to your data. Okay, so fundamentally, functions are very important, and what they do is you give it stuff and input, and they give you back output. That's what a function does. So some basic types of functions. The one we just saw, the mean, is a function that comes with MATLAB, and MATLAB comes with tons of functions. There are some special functions that you can't actually look at the source code since they're implemented at sort of a lower level than a MATLAB function. So those are called built-in functions. I think I can find one. Yeah, there you go. Plus. Plus is a built-in. You're not going to see the source code for plus. So there's built-in functions. There's functions that you can just take for granted because they come part of MATLAB and they're probably bug-free, and you can just treat them as well-written. And then, one second. And then besides that, there are all the functions that you might get from someone through a toolbox or something, or you might write yourself. Question?
Type whatever function it is.
Yes, okay, sure, we can go immediately there. So here I asked mean of a matrix that I typed in at the command line, but suppose I already have that matrix stored in a variable somewhere, like AA, as you just said. So you can just say, what is mean of AA? So what MATLAB's going to do when it sees that, it's going to go look up in the workspace, well, did someone define AA? If so, I'm just going to take what it was, and then compute that with mean. Of course, if you do it on some variable that doesn't exist, it's not going to know what to do. Undefined function or variable. So GH actually could have been a function, but no, I mean, MATLAB doesn't have a built-in function called GH, so it doesn't know that, and neither does it exist in the workspace. If you look in the workspace, I don't see GH, so that's why it gives us that error. So it's issues the error, nothing really happened, it was just like something messed up, fix it. Okay, so that's what functions are. We'll look at how you write a function, but later, but just to introduce you to that concept. And then the sort of corresponding concept, but it's different from functions, are scripts. So in the end, when you write a piece of MATLAB code and save it as a file, it's going to look like a text file, but it's either going to be a function or a script. And the fundamental difference is a function is going to have well-defined inputs and outputs, whereas scripts are just a series of commands. And one more important difference, and hopefully this isn't too abstruse, is that when you specify a function, this is sort of good programming practice, comes from like computer science, but when you define a function with inputs and outputs, the only thing the function can touch or access are what you give it. It won't be allowed to sort of mess with your workspace and change things. It will only be allowed to see what you give it, and it can compute whatever it wants based on what you give it. And it can give you an output, but it's not allowed to sort of go in your workspace and change things. And so that is sort of a housekeeping type thing. It sort of makes it easier to keep track of what a program does, because if a function was allowed to change anything anywhere, then it would be almost impossible to figure out exactly what a program is doing, because you would have to worry about, well, is it touching this variable or that? The contrast here is scripts. A script is just a file that is as if you're typing at the command workspace. So if you're typing right here, you can access the workspace, obviously. So a script doesn't respect this idea of you can't touch the workspace. A script is as if you were just copy and pasting a command in the command window. And depending on how you handle your code, it may be more useful to have a script versus a function. And how that plays out will be more clear, I think, later on as you get more familiar. Question?
So can you run commands from a script that you've already saved on like a new data set, or would you have to copy and paste or like retype or something?
So a script is just a text file. So depending on how you want to handle your workflow, but so right now in my text editor, I can just start typing a command. Here, this will be a script. A script will assume that A exists somewhere and I can do something to A. So done. So this is my script. I'll just save it as test script. The extension is .m, just for MATLAB. So I'm going to save that. It's just a text file. I'm going to save it on my hard drive. And I can run that script at any point. And that script will, of course, give an error if A is not defined. But okay, so let's go back to my workspace. Let me clear everything. I'm sort of jumping ahead. Clear is a command that deals with variables, and here I'm going to say clear everything. So clear all. Then I check my workspace. There's nothing. Fine. So let me define my variable A to be 10. Now I'm going to run my script. So to run a script, it's kind of like calling a function. You just sort of type the name of it. So I define this script called testscript.m, but you don't have to type .m. It's sort of implicit. So I can just type testscript. So if I issue this, it'll just go into the text file and act as if you're copying and pasting whatever's in that text file. So that text file just had, sets B to be whatever A was plus 1. So I just ran it, and it's done. And we know it's done because I get another prompt. If it had to do a lot of computation, you wouldn't see a prompt. It would just be sitting there. And notice that nothing happened. But actually, something did happen. Let me check the workspace. B exists now. Yeah, and the reason it didn't echo out B to the screen was, sort of jumping ahead, there's this idea, if you put a semicolon at the end of the line, it'll suppress that little echoing that it normally does. So right, if I define A to be 10, it echoes it out. But if I don't want to be inundated by all that stuff, you can just put a semicolon at the end, and it'll suppress that. But it still ran. So you can say A is 11. It actually ran. We can check what A is. It's 11. So yeah, getting back to your question, the script, yeah, you can run the script at any point. So if you have a different value of A1 on a different data set, you can just run the script and it'll then compute that. Sorry if this is very basic, but I guess for people completely new, it's fundamental. So, okay. So we're almost done with the first set of stuff. There's M files we already talked about. M files are just text files that either have a function or a script in them. And then the final bit that I think is fundamental are .mat files. So this is how you sort of save your data. So currently in my MATLAB workspace, I have two variables, A and B. And let's just set B to something differently just to make things more interesting. Okay, so I keep typing whos just because I'm sort of obsessive compulsive about that. So I have two values. I think these values are really important, so I want to save them just so I can access them later. How do we do that? Just type the function. Save is actually a function. And this save is a function that takes one argument, the sort of the file name I want to save it in. Very easy. So let's call it data.mat. And it's going to save it to whatever my current directory is. And I don't know actually, so I have this other function which is actually listed in the lecture notes. The directory I'm in is user/Kendrick. Fine. So I'm going to save data.mat in that directory. Done. So there's this file data.mat. It contains A and B in it. So we saved it. If we were to quit MATLAB, that's okay because they exist in that file. So just to prove that to you, I'm going to clear everything in my workspace, clear all, and then check my workspace. There's nothing here. Uh-oh, I lost my results. Actually, I didn't, because what I can do is load, and load is a function, takes one argument, this little file name, and I'm going to load it in. So one notation I implicitly used here was this quote. Quote sort of starts and finishes a string. Like, if I were to type save data.mat, it would try to interpret data as a variable, but that's not what data.mat is. Data.mat is just a string that refers to a file. So to indicate that, I have to use these quotes. Okay, so I just issued a command load data.mat. So it's going to take all the variables in that file and stick them in the workspace so we can play with them and check who's, and they're there. It also has this annoying variable called ans. Remember, ans is automatically created if you don't assign it, but let's just ignore that. The important ones were A and B, and that they do exist, and 11 and 34 were their previous values. So load and save, very fundamental, just so you can save results and load your results later. Okay, so I think that covers section 1. You can sort of follow along, hopefully. Any questions about these very basics? .m files, .mat files, function scripts. Okay. Because I sort of have been demonstrating on the fly, we actually covered a bunch of these things. To interact with MATLAB, just type a command in the command window. Well, we already knew that. If you don't end it with semicolon, it might show you some stuff in the command window, which might be annoying. Fine. We already talked about ants, ans, fine. And then there's this little distinction between an assignment and expression. It's maybe not so important. Assignment means you take a thing, an expression, and you're going to put that in a variable. In this case, the example is you're going to put 1 plus 1 after you evaluate it into the variable A, versus an expression is just sort of the thing on the right-hand side of that assignment, just a series of function calls that produces a number, or a matrix, or a scalar, or something. Okay, so, oh, that was easy. We're done with 2. So, 3. We sort of gone over, we've already used a bunch of these commands in our very basic interactions with MATLAB. We've already used whos. I sort of provide these here as just a reference guide. Of course, I'm sure there's MATLAB references that you can find on the web, or even the MATLAB manual. So we already went through whos. We already went through clear. One different usage is you can just clear a specific variable. You don't want to clear everything. You just want to clear one variable. You can do that. We already went through type, which is a quick way to look at the code that underlies a function. But let me go into that slightly deeper. So let's talk about which. So remember the first function we used, mean. We did type mean, and it showed us the code that underlies mean. Well, mean is actually a file somewhere on my computer. It's probably somewhere in MATLAB's directories. So we can type which and then mean, and it tells us that file, mean.m, exists in this directory. Great. So if there's ever a function call you encountered, you're like, well, what does that function do? Or I want to go edit that function, use which. And which will tell you, oh, that function's actually living here. And you can go open that function up and edit it. So edit, as I sort of just went to, you can edit a function. And actually, since I'm not using the GUI, I'm not even sure what this will do. Oh, okay. It opens up in my text editor. I didn't know I set it up that way. Anyway, great. And yeah, question?
How do you tell MATLAB where to look for functions? Like if you just, every time you initialize MATLAB, you want it to...
Yeah, we're going to get to that in actually the next lecture. But the quick answer is this issue of path. There's a MATLAB path. Path is a collection of directories that it looks for where my end files, and we'll get to that, but that's a good question. Okay, so just going, let me just briefly say about help. If you do type mean, it shows you everything, both this top part, which is the help for mean, and also shows you the code. But if you just want to see the documentation for mean, you can do help, and help will just go in the file, look for the documentation, and just show you that at the command window. So this is the help for mean. And in theory, you should be able to read the help for a function and know how to use the function without actually looking at the code. I mean, that's sort of fundamental to programming. When you build a complex program, there's no way you'll actually know every single command that is used to accomplish something. And if you can break things up into little chunks, like mean, you can just document the mean function and not worry about all the code that is underneath. So in this documentation, you can read it. Probably at this point it won't make total sense, everything that's said here, but in theory when you write the documentation for a function, it should be comprehensive and it should allow anyone to know exactly what are the inputs and what does it do and what are the outputs. Okay. And almost done. Very basic. I mean, this is sort of, I guess if you have a Linux, if you use Linux or the Linux part of, or the Unix part of your Mac, you'll be familiar. But CD and LS and PWD are just basic sort of directory navigation. I probably don't have to go over it. PWD tells you where you are. LS tells you what files exist at that point. And CD can change directories, so I can change into a different directory. Done. And then I can check that happened. Yes, I'm there. And these file sort of navigating directories, you can also do through the GUI. So maybe if you want to use the GUI instead to do that, that's fine. Okay, and we already went over load and save. Of course, one sort of caveat, all of these functions have multiple ways you can call them. And I'm not going to list them all here in this little lecture notes just because otherwise it'll grow into 10 pages instead of 4 pages. But if you want to know exactly all the little fancy ways you can, for example, call save, well, save actually has a long piece of documentation, which may be slightly annoying. But suppose you only want to save one of the variables in your workspace. Well, if you just type save data.mat, of course, that's not going to do it. It's going to save everything. So there's this way of calling save where you just put a comma. And this is actually the first instance of you can give multiple inputs to a function. So in this case, you can give save both the file name and the specific variable you want to save. So that's a way of calling save. It wasn't evident from when I described it, but if you do help on save, you can sort of figure it out. Okay. Any questions? So I need to know, anyone think I'm going too fast? Too fast? Anyone think I'm going too slow? If you don't raise your hand, you're probably lying. So either it's too fast or too slow, probably. Okay. Let's see. For the rest of this, a lot of this is going to be, we're trying to get to the matrix concept, but there's one last bit I put before getting to matrices that we should cover, and that's data types. For the most part, you'll be dealing with numbers and probably strings, and we've already sort of implicitly went through that. So I already defined a number like that. That's your data can consist of numbers like 1 or 1.5 or 0 and stuff like that, and that's a data type. and you can read about it in my little lecture notes. It's called double, having to do with how many registers or how much memory is allocated to storing that number. But the other data type you'll probably want to know about is the string data type, and we've already sort of implicitly done that already. That's like this. So I'm going to set a variable b, and I'm going to set that not to a number, but to this string. The string is just a series of letters and numbers. Done. So I just told MATLAB, set variable b to hold the string data.mat. Okay, strings are useful because we like to name stuff that we measure and so forth. But notice that strings are handled as variables just as numbers are. So I can do something like this. B holds this string, and suppose I want to save my workspace into, instead of just typing out data.mat again, I could just say save it into B, and what's going to happen is when I issue this command, MATLAB's going to evaluate B. That means just sort of look up what does B refer to. Well, B is this string, and so it's actually going to save to a file called data.mat. And we can check what B was. Well, B was the string, and so it all works. So numbers and strings are probably what you'll most deal with. And as I said, numbers are normally double, and you can read what that means. And there's also this other data type that you probably won't use, but I just included it to be a little complete. It's called single. And the char data type are what allows you to have strings. Now there's a couple other, char stands for character. So character is just like one letter. Okay, there are a couple other data types I listed here. As I said, you probably won't explicitly deal with them, but they're important to know they exist. So there's this logical data type that's either zeros or ones. When that gets used, we'll see later. There's also a cell data type. And let's not worry too much about that. I'll just say the word cell so that when I say it later, you won't be totally confused. And there's some other integer data types. Let's not worry about that yet. And then there's these special numbers, and they're not really numbers because they're not finite numbers. So these are somewhat important, so let's go through that. So there's these three special words, nan, inf, and negative inf. So inf is easy. Inf stands for infinity. And technically, it's a number in some sense because inf is not sort of the string inf. They're actually different, and you can kind of see that in how MATLAB spits it out. But what's an easy way to get infinity? What's a math problem you can do to make infinity? Divide by 0, right? So 1 divided by 0 actually gives you the answer inf. Of course, it's not very useful because probably that's not meaningful for your data analysis, but it's a valid number in some sense, and MATLAB can deal with them. Another special word other than inf, as we just saw, is negative infinity. And you can do that probably by negative 10 divided by 0. Okay, good. Negative infinity. And there's also nans, which are annoying, but they're important. So this often is used for missing data. So if you have 3 subjects and one of the subjects didn't have a value for some column, you got to put something there. And so the way that's normally handled in MATLAB is to use nan. Nan means not a number, so it sort of means like invalid data or something's missing. And be careful about nans because if you try to add nans to other numbers, it'll just be confused and give you nan. And there's ways to handle this, and this is jumping ahead, but you can ignore nans when you add, which if that's what you want to do, you can do something like that. And I'm just sort of jumping ahead just to show you. So maybe you do want to just treat them as 0. So in this function, which you could look at the documentation for and so forth, but this just everything that's nan, it just sort of ignores, and that effectively means in the context of summation, treat them as 0. But nans are annoying, but you kind of have to keep track of them. Otherwise, your analysis result might be nan in the end, and that's not very informative. Any questions on basic data types?
Is there a way to figure out like what type of data, like a single variable is, instead of typing news?
Yeah, so that's a little advanced maybe. So let's go ahead and define. So now that you're on that topic, you can cast values into other data types just by typing the name of the data type like that. So if you want to make So normally numbers are double. So if I type f equals 1, the kind of variable it is double. So that's this last column in whos, right? So if you want to make actually f a single variable, you can cast it just like that. Check it, it's a single. And you're asking, how do I find out? Instead of typing whos, you can do class. There you go. So you can, class is a function that gives you the class type out as a string, if that's something you want to know. And you can also check, there's functions built in, is it a double? Is f a double? Oh no, there isn't a function. Okay, there's something like this. Okay, so ignore this if this is about, this is crazy talk, but f in my workspace is a single. I asked MATLAB, is f a double? And it's going to tell me no. And this actually gets into logicals, and we'll get to that in a second. But 0 means no. Does this answer your question?
Yeah.
Good. And then you can, of course, ask, is f a single? It should say yes. Oops. Yes. Okay.
If you want to concatenate strings,
Yes.
but you can't just add them together like you can't do that to treat it as a double then, is that right?
Yeah. That's fine. I can jump to that comment. So Todd's asking about what are strings? How do you play with strings? We know how to play with numbers, right? 1 plus 2, easy. For strings, this is sort of a weird idea, but that's why I'm going to use the string weird. So the string weird is 5 characters, and it turns out MATLAB represents strings using matrices. So what does that mean? So let me set a variable called str to this string weird. Fine. Let's go look at what it thinks str is. Well, str is actually a matrix that's 1 by 5, and that makes sense because there's 5 characters, and each character, and it has it's a vector of characters essentially, and so that gets a little bit in how MATLAB implements stuff. So suppose we want to construct the string weird stuff, and so we want to add to that. So suppose I have that, and I want to sort of tack on this extra string to it. So there's 2 strings. One is 5 characters. The other one is 6 characters. Because everything's a matrix, including strings, we basically need to concatenate these 2 matrices together. And so just as we concatenate numbers using these square brackets, we concatenate strings using these square brackets. Okay, so let me show you the parallel. So this is a vector of 4 numbers, and I indicate that using square brackets, and I type the 4 things that get put into a vector. MATLAB's happy, and that's the analogy with this. So here I'm actually concatenating 2 separate vectors. So actually here's an example that's a little more parallel to this concatenation of strings. So I can concatenate 2 vectors. So here I have, and this may look a little weird, but I guess once you get used to it, it's not weird. I'm telling MATLAB, take this vector of 4 numbers, take this vector of 4 numbers, and then just concatenate them together. And that's indicated by putting another set of square brackets. So after that, yeah, we typed it in with nested brackets, but after you issue this and evaluate it, it's just 1 vector. So what I just typed in is exactly equivalent to just 1, 2, 3, 4, 5, 6, 7, 8. So these are equivalent. Yeah, so what Todd asked was, can you do something like this? In the world of MATLAB, that makes no sense. That's like saying add a vector of 5 characters, like add in the add sense, not concatenate sense.
Interprets them as a number, so
Yes, there's one other subtlety here, which is characters are actually numbers if you make them. So normally they look like characters, right? But if you convert W to a number, and ignore this if this is just too complicated, but you can make W into its double representation, meaning a number representation, and it's actually 119. So computers, anyway.
If you write like you did above with a bracket and then an internal bracket and then it quotes weird and then the same thing quotes stuff, does it take it as the vectors that it used to be, or is it like confused by that concept?
So once you evaluate this selection, it is just a 1/8 vector.
Right, but instead of, I mean, the way you tried to concatenate it before was you like had quotes, weird quote stuff, but each one was an individual vector, right?
Right.
So if you had done it where it was like bracket and then like treating them like they were vectors in the first place? Yeah, is that
Something like that. No, everything just gets smashed out. Everything is just flattened out into a single. It's exactly the same. You can put, okay, so for that end, you can do this, and all the brackets just go away. It's just.
So how do you build a like if you're trying to build a multi-dimensional vector or like matrix or whatever, how do you can't specify internal brackets?
Great segue. That's sort of the next part. Okay, so all we know how to do is make one-dimensional vectors that sort of are horizontal. How do we make a two-dimensional vector? Well, we use a semicolon. So actually, let me make it, okay, so this vector will be 2 by 3. So 2 rows by 3 columns. So I'm done typing the first row. I want the next row, so I just put a semicolon. And the white space doesn't matter. So you can put the semicolon anywhere. Semicolon means go to the next line. So once I type this, and let me assign it actually to a variable. X equals this. Done. X is a two-dimensional matrix now. It's no longer a vector because it has stuff in more than one element in more than one dimension. That makes it a matrix. So this is a 2 by 3 matrix. And check what X is. X is, lo and behold, 2 by 3. Great. So we use semicolons. When we're entering in matrices manually, you use semicolons to sort of indicate go to the next line. So the segue then is we needed to really understand matrices, and that's what section 5 is. Any questions before I go there yet? Okay. Let me just look ahead briefly to see how much I want to get through. Hopefully this is not overwhelming. I mean, I dedicated only 2 class meetings to learn everything you need to know about MATLAB, so if you know this lecture and then keep it up for one more, I think we should be in good shape. Okay, so matrices. So some just terminology. Each element of a matrix is just the individual parts of it. So X consists of 6 elements, that's 2 and 3 and 4. And not only are there elements, but they have a specific structure, right? This matrix could have been 2 by 3, or it could have been 1 by 6, or 6 by 1, and they're not equivalent. So the shape of the matrix is very important. Okay, so there more terminology. So individual numbers are sometimes called scalars. I don't know why. Let's just say that's what it is. But really, as we saw earlier, a single number is really a matrix. It just has 1 by 1 dimensions. So there's scalars, there's vectors. So far we've been dealing with row vectors or horizontal vectors that has the dimensions are 1 by n, where n can be some number. But you can also have column vectors. So the dimensionality is n by 1, where n is some number. So we have scalars, we have vectors, and then after that, everything you just refer to as a matrix. And so matrices can be 2-dimensional, they can be 3-dimensional, they can be arbitrary dimensional. So let's look at some examples. We already looked at this very simple 2-dimensional matrix. Let's make a 3-dimensional matrix, but immediately, probably you can see a problem, which is how do we visualize that or even see that on our screen? So I'm going to do a very simple 3-dimensional matrix. So rand is a function. We'll get to that in a second. But I just want a 2 by 2 by 2 matrix. So there's a total of 8 elements. That's fine. So rand is a function that draws a random number between 0 and 1. And it does that independently for every element in this matrix I'm trying to create. So I asked it, give me a 2 by 2 by 2 matrix of random numbers. And it did it, except that, now it spits out these 2 separate outputs, because really visually we can't see a 3-dimensional matrix very easily. So what it's going to do is show me the first slice, and this is a term, maybe I should put in the lecture notes at some point. I'll just make myself a little note, slice. A slice is just like a portion of a big matrix. So in a 2D matrix, individual rows you could say are slices, or individual columns are slices. In a 3D matrix, like think of a cube. If you have a cube, you can sort of slice the cube into this slice. Oh, like fMRI, if you deal with fMRI, slices. you can have a whole volume, but actually each part is just a slice. So here, MATLAB sliced it along the last dimension, and our matrix is 2 by 2 by 2, so really there's just 2 slices, each of which is a 2 by 2 matrix. So the notation here is new, right? We haven't talked about what is this weird parentheses stuff, and we'll get to it in a second. But ignoring that for a sec, you can kind of see, first we see the first slice, the 2 by 2 set of numbers, and then MATLAB is showing us the second slice. This makes sense? So that's a 3-dimensional matrix, but guess what? You can make whatever dimensional matrix that is, and it's going to be ugly, because now we see this, and there's no way we're going to make any sense of what the structure is here. So we don't want to see that, so I'm going to put a semicolon at the end. Done. So it executed. I just didn't bother me with showing me what it was. Let's just check the workspace. X is a 7-dimensional matrix. Great. Okay, so MATLAB is very good for working with matrices, and if you think about the kind of data you collect, probably in Excel, I don't know if no one mentioned Excel, but Excel is a 2-dimensional matrix, and it probably is horrible for dealing with 3-dimensional data, but MATLAB does it great. Except, I mean, it's hard to see, but it's easy to work with. You can program with 3-dimensional matrices easily. Okay, some other basics about matrices. There's an empty matrix, and why that's important, it's probably not clear yet, but so imagine you were constructing some data. So X was 1, 2, 3, and then you maybe process the first one, and it becomes 1, 2, and 3, and then you process number 2, and then it's just 3, and then you process the last one. What happens? Well, it's still okay. It's just a matrix that has nothing in it. So let's look at the dimensionality of X. Here it reports X as having 0 by 0 dimensions. So it's an empty matrix. Again, I'm not sure it's apparent why you care yet, but it will come up now and then. So I just, as a warning. Okay, and last bit, if you want to like start playing with matrices and you don't want to type a big long matrix, I've already used one way to make a matrix, rand, and there's, I guess, a couple other ways. So in other words, you can directly type in a matrix using the numbers and semicolon and so forth. You can make a matrix using a function like rand, and there are a couple other functions that can make matrices for you. Zeros is a function. The arguments to this function are just the dimensions you want. So you want a 10 by 10 matrix of all zeros. So the first argument specifies the number of rows, second argument specifies number of columns, done. And in this case, I won't end it with a semicolon just so we can see it. So it just shows us visually what is the matrix. Yeah?
Just a general question. So I noticed that you've been using like the same variable name for different things. So how is it saved on the workspace if you were to call it that variable?
Oh yeah, it totally overwrites.
Okay.
I'm just reusing the same letters just because I have no imagination, but all the previous values are lost completely. There's no undo, I think. There's undo when you're editing a text file in the GUI probably, but in terms of variables, but there's no undo. Okay, so here I just use zeros to make a quick 10 by 10 matrix. I can also, there's a function called ones. Same idea, except everything's a 1. So these are useful functions just to make a matrix really quickly. Of course, it would be really painful to type out this matrix by hand. Okay, any questions on matrices? Hey, we're almost done with the very basics of matrices. There's this last bit that we have to slog through, and then everything else is just function calls. Okay, this last bit we need to learn about is this idea of indexing. So indexing is kind of a way to selectively access part of a matrix. So, for example, we already have this matrix X, and we want to, suppose we want to access a specific element in this matrix. This is very much like math notation, if you've ever taken linear algebra or something. Basically, you use parentheses, so don't get confused. Remember parentheses, smooth parentheses were used to indicate the arguments of a function, like right here. But you can also use parentheses to index into a matrix, and that just means sort of pick out the elements in this matrix. So using that idea, we can say X, which we've already defined, let's pull out the element that's in the 7th row, 2nd column. Unfortunately, this example is kind of dumb because all of them are 1, but let me just make a better example. Okay, X is a 3 by 3 matrix. Let's pull out the element that's in the 2nd row, 3rd column. Order really matters, right? A 3, 2 is not the same as A 2, 3. So first number is the row, second number is the column, and so the answer is 0.653, right? Okay, so this is a notation. Don't get confused with function calling. Of course, there's this issue, maybe you're wondering, what if X is a function and it's also a variable? What the heck happens? And let's not worry about that yet. In this case, X is a variable, it's a matrix, and we can index into it, and we just did so in this fashion. All right, suppose you want suppose you want the entire row. Suppose you want to go one row by row through some data. There's this, let me do it manually. So I want the 2nd row. I can say I want row 2 and then all of the elements 1, 2, and 3. Okay, so this syntax is a little interesting. I'm using a vector in the indexing part, and that's valid. This is saying pull out all the elements, they all exist in row 2, but pull out elements 1, 2, and 3, which is the entire row. And so you can kind of pull out this slice of the matrix and I'll return it to you. And so, of course, I can do something like assign that. So I want F to just be the 2nd row of the data matrix X. I can do that. Done. So a couple modifications. So now that we can use vectors to index, we can kind of make any crazy vector we want. Suppose we want elements 2 and 3. Done. Or we only want elements 1 and 3. Done. So there's a lot of flexibility in how you can pull out different parts of the matrix that you need. And then, of course, it gets cumbersome to type 1, have a big matrix to type 1, 2, 3, 4, 5, 6, 7, 8. Suppose you want everything. You can use this kind of syntactical shortcut. It's just a colon. Yeah, so for now, just take it as is. You can use colon. It essentially means everything. So it takes the entire row. And some other shortcuts. Suppose you want, let me just make my matrix bigger just for fun, 5 by 5. Suppose you want everything except the last column of this matrix. Well, there's different ways to do that. I'll show you the boring way. So if you want to ignore just the last column, then we want to do something like, I want all the rows. I don't care about the rows. I want all of them. And I want columns 1, 2, and 3, and 4. So that's one way to extract all the entire matrix except the last column. But it's a little cumbersome. It's ugly to look at. A different way is to say, I guess I should have introduced this operator. Back up a second. I need to talk about colon. So we already seen colon. There's multiple uses of colon, but colon is an operator that kind of does expansion for you. So 1 colon 4 means 1 through 4, and it sort of expands it into a vector. So you can do 1 through 10, and it just makes a vector. So it's kind of a shortcut. So we wanted to index out everything except the last column. So I could have said, okay, X, I want all the rows, and I want columns 1 through 4. So instead of typing out 1, 2, 3, 4, I can just type 1 colon 4, and MATLAB automatically, expands that out into what you need. So that's good. I'll just do that, just to prove that. And there's one other shortcut that I was trying to get at to do the exact same thing, which is 1 through end. End is just another sort of special word, just like colon. Colon's a special word or symbol. N refers to the last index that's possible in your matrix. So in this matrix, it's 5 by 5, so the end is really the number 5. So it's literally treated as 5, and so we can do things like n minus 1. So that's another way to pull out what you need. And why is this useful? It's useful because you have a piece of code, maybe it wants to be a general piece of code that can work with any size matrix. You don't want a hard code, oh, there's 5 columns. You can just say, oh, just pull out everything except the last column, and you can do that in a general way by using the word end. Okay, So indexing is very important. Allows you to pull out, and indexing can get complicated. So let me just show you an example. So you can say I want stuff in rows 1 and 3, and I'm not sure anyone would actually do this, but I'll just show you what you could do. You could do that. So this says extract out 1 and 3, those rows, and then I only want columns 3, 4, and 5. It's very hard to think about, so maybe you wouldn't want to code it like that, but you could do that if you needed to. Okay, we're almost done with indexing, and then I think we're kind of home free. Okay, we still have our matrix X, and so far we've used indexing as just a way to extract data from a matrix. But you can also use indexing to put data into a matrix. So far we haven't introduced that concept at all. So far we just know how to assign sort of en masse stuff to a variable. So all we know how to do so far is say x equals either a thing we type in manually, the result of a function like rand, but we haven't learned how to change. Suppose we messed up and we want to change this column to something else. Well, we just use indexing. Let's start with the easier example. Let's just change that element, the second element in the first row. So we just go first indicate the position of the element we care about, and then use the equal sign. So this is a new notation. We can actually use an index on the left-hand side. So this is not a variable. This is saying in this variable, talking about this element, then assign it to something. So we can say make the element in the second column, first row, to be 10. Done. So notice what happened. It returns, sort of this is a convention of MATLAB. Yeah, we only modified this element, but it's going to return the entire variable that we operated on. So it's going to return back to our screen at least the entire matrix X. But the only element that was touched was that one element we told it to do. And so you can immediately imagine more complicated things like let's modify 2 things at a time. So I want to replace the second and third elements and make them 10 and 11. Done. Let's do the same thing, but do something. This is a kind of a shortcut. So we're taking 2 elements and we're setting it to a single number. In some sense, that doesn't make any sense because you need to specify 2 values, but this is a shortcut. MATLAB allows you to put a single number on this side and it'll automatically dish it out to all the elements. So that's very useful because suppose we want to zero out the entire first row. So we would say, oops, x is our variable, first row, colon, set them all to 0. That's much easier than typing 0, 0, 0, 0, 0, 0, but that could also work. Okay, any questions? I mean, those actually are the fundamentals. And then after that, we just have, you got to learn some new language, I guess. There's these basic functions, and we already know how to call functions. You just now need to know what functions they call to do what you need to do. So any questions on matrices, indexing, numbers, strings? All right.
So I've got like a question on like it.
Sure.
I don't know, weird. But so what is and like is it a function or it's like you can only use it inside of
You can only use it inside of indexing. So I would view it as sort of a shortcut. It's not really a function that gets evaluated. It's just this sort of syntactical sugar, I think is some CS term that.
Okay.
Yeah, here, let's check. Help end. Oh, wait. wait a minute, is n actually a function? Okay, n technically might be a function, but, so I eat my words, but I've never seen n called as a function. Although I guess you could argue that this is a function call. Never mind. Erase your brain. Ignore what I just said. Oh yeah, I mean yes. Oh yes. There's n to n for loops and stuff.
The other end is not a function. It's just an implicit variable that's defined for when you're working inside of a matrix. So every time it says the end to the end. So how do we call it?
Wait, no, end is a function. Look at there. You can call n as a function to get the end. Ah. Wait, in this case, when you're working with for loops, it's not a function, I'm pretty sure. Okay, but, or maybe this is what you said. Anyway, these are things you don't actually need to worry about to use MATLAB. Okay, we're getting kicked out of this room, so I think I'll stop there. So, I mean, just in terms of MATLAB, we're going to learn about MATLAB for one more lecture, and there's a homework just on basics of MATLAB, and by the end of the next lecture, you should be able to do that homework. In theory, you could start trying to do the homework now, I think. Or maybe you just at least want to look at it. It's not hard. You can answer the homework in like 1 page, 10 lines of code or 20 lines. But of course, what lines there are may be very difficult, so you may want to start now.
So for the homework, do you just want us to create like one script file and a bunch of functions inside that script file?
Yeah, so here's my answer to the homework. It consisted of, well, wait. I say what to create in the instructions. To complete assignment, prepare a file, text file, called that. So you're going to create a file, and it's going to involve creating one more file. That's a function file. And then you're going to run this special MATLAB command. And then you're just going to print out. So actually, I just want some printouts. But it involves writing a couple script files. And
so you write like separate .m files
mm-hmm.
for each function that you make.
Right.
So one being involved in one.
Yeah, so functions, I mean, sometimes you can define a function with other stuff, but normally functions are their own thing. So if you, part of the completing assignment will be to write one function. So that will be its separate file. And then the rest, the main file will just be the answers to the questions. Okay, and one last thing, just remember, if you have any, even if they're really dumb questions, ask them, because I don't want you to waste 10 minutes or 20 minutes or 30 minutes trying to figure out how to do something, because I can just tell you in a second. And yeah, so if you have those questions, click on this link and just ask them at this website so that everyone can see it. All right, that's it.